Hello everyone, Seth here from CubeLife Productions, and welcome to a code video. I'm actually going to do some coding for you guys, and I don't anticipate this taking actually very long at all. It seems like a pretty straightforward program for me to code. I tried doing this last week, and it just took freaking forever. But now that I'm kind of back into it, we might as well do this. So obviously, what I like to do with any code is I like to start with a little pseudocode outline. So if you don't know what pseudocode is, you have actual code, and then there's pseudocode, which is a way of saying, code for human speak. So it's a lot like taking code, like a line of code, and basically describing what does this code do in a way that anyone can understand it. So something like cout hello world, the famous line. Cout hello world, translated into pseudocode, would basically just say display hello world, and that would be your sort of pseudocode equivalent to this line. So anyway, at least that's from my experience. I'm not sure if anyone else does it differently. I'm not sure what the official way is. That's just what I picked up from pseudocode. But anyway, we're gonna make our quick little code outline here. So if we will, we're going to go ahead and start with our program purpose. What is our program supposed to do? So we have this lovely text file here that is absolutely filled with data, hundreds and hundreds of lines of data. If I can recall, 260 lines of data, but separated into pieces of 4 separate chunks of data. So what these are aircraft carriers, and we have the name of the carrier, the year I think it was commissioned, and the year of its eventual demise or end of service, and then the resulting status of that craft. So we have quite a few of them, and as you can see further down, we've got some more complicated names. Here's an interesting status: inactive, unfit for service. So I think the ones that are 0000, which means they are still here. That's our data that we have to read into. And we have to read that into a file and then pass it on to a second text file that is, I believe, at the moment, not even here, but it's empty, and it's going to be called a2.txt. And it will be created when we run our program for the first time. But that is going to store all of our data in a formatted way, which is kind of detailed here on my assignment sheet. So we're going to take that data, which we'll just use this example, Langley, 1922, 1942, and sunk. And we're going to format that into carrier name, Langley, commissioned, 1927, 1922, my bad, decommissioned. Don't want to, dishonor the carriers. 1942, and then status sunk. And we're actually going to have all of these arranged out in such a way that they are going to be like nice and even, like this. Yeah. So there you go. That is going to be our output to the eventual text file, and that will just allow us to. We're also going to have a line separating each one, so we're going to have like data piece 1, skip a line, data piece 2. So that's going to be our eventual result from the data that we have in this file. And we're not going to store all the data. What we're going to do is we're just going to pass it through the program. And I'll show you what I mean by that here in a second. So let us begin with talking about the libraries we're going to need to include. Now, C++, basically, the version of C++ that we code with includes several base libraries that allow us to use things like, the cout command, basically input-output commands, manipulation commands for like formatting data, as you saw with like the tabs and indents and everything. So let's go ahead and make a list here. So we are going to include, and let's go ahead and let's kind of make a little title here, program outline. Super official. We're going to include definitely our IOStream library. Not IOSteam. Steam is not affiliated with me. Okay. We're going to include our IOStream, our fstream, which allows us to read and write, which allows us to read from and write to files, and our IOmanip. Whoopsies. IOmanip. There we go. So those are our 3 libraries that we're going to include. So IOStream is going to allow us to do like input-output for basic console stuff. fstream is going to allow us to read from and write to text files and just files in general. It'll allow us to interact with files. And IOmanip will allow us to do the lovely tabs and formatting and all of that. So that is how we are going to roll. So we're going to include all those libraries, and then we are going to declare our carrier structure. Now, one of the big things for this assignment is the idea of a structure. Now, in C++, you have all of these different types of data that you can start out with. You have int for integer. You have double for a double, which is like decimal. You also have float, which is another one of those things. And there are, some variations on those. And you also have things like a string. Also reminds me, we need to include our string library. There we go, string. Either that or it's C string? I don't know. We'll find out in a sec. But I think it's just string. There's a string data type, which is for things like names, words. There's the char data type, which is just for characters, like I, or a number, or a symbol. So those are all what are called primitive data types. So what structures allow us to do is define what are called ADTs, abstract data types. And these abstract data types are basically composites of primitive data types. So what this carrier structure is going to be made of, structures are ways for us to define these abstract data types. So there are ways to tell the computer, the program, what it means to be an aircraft carrier. What data comprises the representation of an aircraft carrier. So in this case, when we're looking for an aircraft carrier, we need a string, which is going to be the carrier's name. We're going to need an int, which would be the year of commission. We're going to need another int, which is the year of decommission. And then we're going to need another string, which will be our current status of the craft. Well, current status, I guess, works. So those 4 are what we are going to define to the computer as being an aircraft carrier. So really, an abstract data type is just a composite of these different primitive data types that you can use to make up things like a city. So for a city, you do a population, longitude and latitudinal coordinates, the string, which would be the city's name. You can do all of these things. You can have as many as you want, and then you can actually declare a variable. You can create a city within the program. So it really allows for that sort of versatility. So we're going to declare our carrier structure, and then yeah, that's right. That happens before we go to our main function. Main function is what it suggests. It is the main function that our program runs from. It calls all other functions and does all operations for the program. So our main function in this case does literally 2 things. It runs our run function, and it also returns, after that, it returns 0, which is an integer, which means 0 errors, no errors. So if you go through that program and it finishes up, that means that it did not encounter any technical errors, no runtime errors, no nothing, and the program is complete. So I forgot to do this. So now we are going to go to our run function. So this function is supposed to do everything. So we've got our run function. And if you guys know, I did not really plan this out before. I'm really just making it up as I go along. This is how I plan it. So we have our run function, and it's going to be a void type, which means it is not going to return any values back to the main function when it finishes. It does all of its stuff, and then it's done. And it's also no parameters. I believe that's the name. Parameters, arguments. I'm not quite sure how that goes. But basically, we're not going to input anything into this function that it needs to use. It is literally just going to run. And we don't need to give it any data to work with because it's going to work with all the data inside. It's going to declare and call the data from inside the function itself. So our main function in this case is really simple. Last time it's a little bit more complicated. But once you get into more complex programs, you find that your main function is actually going to shrink, and your amounts of other functions are actually going to grow because you dedicate them to specific functions, which is why they're called functions. So no parameters or arguments. I believe that's how it works. I'm not sure how it's called. I'm sorry for any instructor that happens to be watching this. And then what we're going to do is we are going to create, we're going to declare a carrier. Woo, hello. Carrier. So our first carrier, we are declare carrier. And we're going to call it temp. Why are we calling it temp? Well, I mean, that's just how it goes. No, but really, what we're going to be doing is the temp, when we read in from our sample text file, which we have right here, we're basically going to read in 4 of these values into the temp carrier variable. It's going to output it to the text file, and then we're going to read another 4 values. So what's happening is the data is literally just being passed through. So read in carrier name, read in carrier commission. Oh, wait. Well, one of the things we need to do is we need to declare input file stream. Now, this is where we get into the file stuff. So we are going to declare a file stream, which basically means we are opening up a pathway into the program that we can read data in from a text file, which will be this file right here. So declare input file stream, and then we're going to use, we're going to open carrier.txt with inputs file stream. So that means that this carrier.txt is officially our input file stream. We are going to be reading data in from that file. So now that that is open, we can go ahead and we're going to declare our a for loop. So a for loop says for loop 65 instances. So the for loop is going to run precisely 65 times. And for each time, it is going to read in the carrier name. It's going to read in the carrier commission year. It's going to read in our carrier decommission year. And it's going to read in carrier status. There we go. And then that's what it's going to do. And then for each of those, it is also going to output format the data. It's going to output it to console, so it's going to put it out on the little program screen, and then it's also going to output, let's see.
Don't worry, I'll take a
You know, it might be a good idea to, let's see. Yeah. So we're going to read it in from read in all of that data, and that closes the for loop. So we're going to go ahead and...
When does that ever happen?
I just realized I messed this up a little bit, just a wee bit. So once that's done, we have to close the file stream. So, actually, no, we can do that all at once. I was kind of right. So once we declare our input file stream, open carrier.txt with our input file stream, we can declare our output file stream. And this will allow us to write out to a file. And then we are going to open /create, at least when the first time we run it, we're going to open /create a2.txt, which is basically the output file for assignment 2. This is assignment 2. So once that's all said and done, with output file stream. Okay, now we are good. So read in carrier name, read in carrier commission year, read in carrier decommission year, read in carrier status, format data, output to console, and then we're going to write formatted data to file. Read in carrier name to temp. Just gonna go ahead and like copy that to all of these lines because yeah, there we go. And oh, right there too. Boom. So once we do all of this one time, it's gonna loop back and do it again another 64 times basically for all of the sets of data in this file. So that is basically the program right there. It sounds like we're doing a lot, but in reality, it's actually, I won't say simple to code, but if you know what you're doing, it's a pretty small program. So thankfully, I have my coding console up right now, so we can get started. Maybe that's it. It's when you're going from an integer, it's when you're going from reading a numeric value to reading a string that you have to do that, not vice versa. At least I don't think. So let's build, compile, build, start. Ah! Ha ha! Ah ha ha ha! Oh yes. Oh yes. There we go. Now, we lost the command line because there's so much data, but I think if we go into our beautiful little text file that we have and open it up, it's going to have all of our wonderful data beautifully arranged in format. The eventual results, it did work. We had to do some interesting finagling, and I'm actually gonna send this over to my professor, but to see what she would think about that. But we had to do some really weird IO manip to get these 4 zeros to display properly instead of just a single 0. So, is this something I should have agonized about? Maybe not. But it's there in the sample output, so it's something that we have to technically replicate. But anyway, that's the completed program, guys. I mean, it didn't take too long to code. It took about an hour. Actually, yeah, it is about an hour at this point into the video. Well, I hope you guys liked that video. Kind of gives you guys a little insight into what I do on the professional side of things, what I'm doing when I'm not making videos or stuff like that. I'm learning code and learning how to do interesting stuff like this, which should come in handy someday, I would hope. I really do hope it would come in handy, but it's really cool to know how to code and to know how things work. So, I hope you all enjoyed this video. If you did like, please hit that like button. If you did dislike it, I mean, hit the thumbs down. I mean, express your opinion honestly. But if you want to see more of things like this and film videos and other cool stuff, be sure to subscribe, and I'll obviously get you more of those videos into the future. And as always, I am Seth from Cubicle Productions, and I will see you in the next video.